Welcome to Coding After Work stream. Before we start, we would like to thank our sponsor, Progress Telerik. They have amazing Blazor UI components with over, I believe it's 75 components right now. It's amazing. So if you're working on a Blazor project, you should definitely give that component suite a try. We will add a link in the chat later. If you're already following us on YouTube, or if you're not following us on YouTube, I should say, please do that. Plus, just click the subscribe button and the little bell so that you will get notifications whenever we go live. But now, let's bring in our guest. Now, we tried to figure out what his last name was pronounced like, and I'm not going to try it.
He doesn't have one.
Yeah, so welcome,
That's
Julien.
how bad we are. Welcome. How are you doing?
Hi, nice to meet you. Yeah, I'm like Bono. I'm known with a sing or Madonna, I guess.
Yeah, Madonna.
That's how things work for me. Doing good. It's been kind of a strange time, but we're making we're adjusting, and things are still moving forward. So that's been really fun to actually we're working on C# 10 and we're getting really close right now, so that's been exciting.
Exciting.
So for today, what we discussed was kind of helping people get an idea of what happened since C# 6, which is a lot. So I don't pretend I will be able to cover everything, but basically I thought about what are the features that made the most kind of direct impact, that some of the features that we use the most, and I think your listeners and subscribers will enjoy as well. So
Awesome.
Before we get started, I wanted to give a little bit of context because C# 6 was actually kind of a big milestone. That's when the C# compiler was rewritten and shipped. So that was known as Roslyn. In short, for people who don't know, so there used to be a compiler written in C++. It was a compiler that you would just run from the command line, but what it meant was every new feature would need work in the compiler, and then it would need separate work in the IDE and any other tools that needed to understand C#. What Roslyn changed is the compiler is a library, so it's a set of APIs, and it's shared for multiple scenarios. And so that means it powers the IDE. So Roslyn is used, in Visual Studio. It's also used in Visual Studio Code and other editors. Also, one thing that changed at that time is we shifted to open source, and I will share those slides later on. But you can find us on GitHub. And we're github.net Roslyn. And I opened a document, which is our language feature status page. And basically, this is our kind of work in progress. So it has like the history of previous work that we completed, and it also has what's going on now. We also have .NET C# Lang, where the language discussions happen. We post meeting notes there. We post our specs. This is the language history. It's pretty easy to find, and we'll cover some of those. And another thing that happened in the last few years that is useful to give a little bit of context is the entire .NET ecosystem shifted. It shifted away, basically it used to be really focused on Windows desktop, and it basically became much more open to other platforms, Linux in particular. And that had some kind of effects on the language as well, because now it opens some new possibilities of evolving the language and the runtime and the libraries, everything together. The runtime is no longer shipped as part of the operating system, so that means you can have like different versions side by side, and it just made it a lot easier to evolve together. Today, I don't think I'm planning to talk too much about features that are such features. Most of the features I'm going to cover are not really tied to a specific runtime, but they may require some types. Basically, what we say is it's supported on, like the new language version is supported on the new platform, but we don't really do anything to prevent people from using it down level, and it typically works. And the last thing I want to point out, a kind of a general thing, is that although the new architecture has made it easier to make changes, that it's really solid design, but all this fast change should not scare people too much, because we still place a lot of emphasis on backwards compatibility. So we do have documents on GitHub. Whenever we make a decision to break compatibility, it's been pretty rare instances, or pretty corner cases, I should say. So anyways, I encourage people to try new language versions, and they shouldn't expect their existing code bases should break or anything like that. So
That's always good.
Since
Yeah,
I want
Breaking stuff.
right, I mean that's and it places a lot of restriction on language design. It makes it quite challenging. There's a lot of decisions that would be a lot easier if we could, start from scratch or break things. That's for sure.
Yeah, I can't even fathom designing a language when you have that much. I mean, you're up to level, what, the 10?
Right,
So
we're
you
about to
have
ship
so
C# 10. Yeah.
Yeah, that's insane. I have issues just not breaking stuff in the code.
One of the
yeah.
good things is, in terms of principles, we do not maintain each language version as a completely separate thing. So the compiler, you can turn on new language versions, but we don't tend to have like really different behavior. If basically the principle is that the setting for new language versions only affects diagnostics, but in terms of our understanding of the language, it will always use the latest understanding, if that makes sense. So like we don't end up having like a test matrix that's completely unmanageable, or we have to keep track of like permutations. We just have to say, okay, if you're in a newer language version, then the feature works without complaints. If you use it before, then we'll just complain, but everything still works. All the logic was the same. So that does make the work a lot easier. Since today I won't be able to cover like all the features, I've Matt Storgerson, who's the lead designer for the C# language, has a blog post every time a new version appears. It's on the .NET blog. So those are really good resources. We also have a lot of work done on the docs.microsoft.com. And we have the language history, which I kind of alluded to earlier, this one on the C# repo. And all of these basically link to useful documents, usually the spec or some write-up on the feature. And then, if you look on YouTube for Mads, Bill Wagner, John Skeet, I also really like the NDC conference. You find a lot of good content there. All right, so that's enough context for today. So since I won't be able to cover everything, I kind of picked some features that I think would be useful for just lots of people. I think you guys are planning kind of follow-up on more performance-oriented features since .NET Core, which is now .NET, made a lot of inroads with the performance, and the C# language kind of aligned with that and contributed to that. So there's really good stuff there, and then source generators also, which is a whole area. So for today, we'll get started with some small features, and then I'm planning to cover local functions, pattern matching, nullable reference types, and then if we have time, we can try and cover tuples and records. I won't go super deep, so I'm sure I'll miss some things. My approach is more kind of as an introduction. So don't hesitate to. I will try to make pauses here and there. Don't hesitate to interrupt me if you have questions. Although I have some slides just to give an overview, most of our time is going to be in code. So let's just go straight to that. So here are some of the features that I kind of appreciated the most in that time frame. Starting with a number of small ones. All right. So previously, also a kind of a general note. I did not make like real code and or pulled some of our production code or stuff like that. So I made a lot of small kind of toy examples to illustrate, but it's don't consider it to be like useful or anything like that.
So if it compiles, then ship it. That's what we learned.
There you
right?
go. Yeah.
Isn't that
Copy
what
and
we always
do? So all right. So we've had default expressions for a while. I think it came with generic, so probably C#2 or something like that. But one of the annoying things is you have to keep repeating the type. We have other expressions like null, where you don't really have to say this is a null string or null object. And so we basically decided to do the same thing for the default expression. And we also have like kind of IDE support that will guide you towards using those features. So now you can just omit the type, and we figure it out from the targets. This can be used, in lots of contexts, not just in parameter lists and some such. So some of the features the features I'm listing here are basically things that I hope that once you've seen it once, you'll just use it. You don't have it will just be imprinted. There's not that much to understand in a way. That's kind of what I like about those features is they should be just really comfortable to use, if that makes sense. So a second one that I wanted to mention is out variables. So it's common to have, like when you have out parameters, like this dictionary. Okay, so for one thing, like sometimes you have to initialize it, and again, it's useful to not have to repeat yourself. But then when you want to use it, normally you have to declare your variable, and then you call this method. What we now allow is for you to inline the variable, so it's now part of the call. And if you don't want to repeat the type, then you can use an implicit type. So you can just use var. And that streamlines a lot of calls. There's try parse and methods like that that use this kind of pattern, and it's pretty convenient to use this. All right, so there are cases where you have values that you really don't intend to use. People often use the underscore as an identifier for something. Basically, it's the name for something you don't really care to name. So you will see, sometimes you'll see lambdas where people will have _1 or _2, those kind of things. So we've kind of made that into a pattern, and you can use the underscore, and basically this is it's like a black hole. It's a variable where you can write, but you can never read anything out of. You can't reference it anywhere else. We had to do that. This is an example where we had to do that in a way that's sensitive to existing code. So there are still cases where the underscore will remain. For example, if you could create a local called underscore, and that is still a local, it's still its name, and you can use it elsewhere. So we're still careful for not to break that, but you can now use the underscore. There's a number of places where you can use it. Out variables is one such example, or lambdas is another example, where, oops, not this one. Basically, you can, if you have multiple parameters to your lambda, but you don't plan to use them, you don't have to spend time trying to give them names. You can just use underscore and move on.
That's convenient.
So, all right. Then another one that's one of my again, like a small feature. I classify some of those features as just removing annoyances. So these are kind of smoothing out some of the existing language. So you probably already know about named arguments. So it's especially useful when you're passing values that are not immediately obvious what it's for. One of the issues with named arguments was that you had to name all the arguments from that point on, which could be just PDS, even though we have support in Visual Studio to help you out. So now we also allow for argument names to be placed on arguments anywhere in the list, as long as things are still in order. This is not really helping the compiler much. It's just helping users read the code better. So it's pretty useful for code reviews, and whenever you have these values that you pass in, and somebody's like, okay, sometimes it's hard to map from the list of arguments to exactly where they match in the parameter list. And so this is one of the small features that helps that some. We actually spend a lot of time in code reviews, so trying to help trying to keep the code readable is quite important. All right.
I think that was a very useful feature.
Right, and it's one of those features I think most people won't really notice. They will just, as long as you know it's there, you can just use it and don't have to worry about it too much. So,
but that's kind of the definition of a good UX.
Mm-hmm.
Things that does not bother you is good.
Right, exactly. Yeah.
You don't know what it is, but it works.
Right. It's if we can keep it invisible, and if it doesn't add to people's mental load where they have to remember the rules and things like that, that's all the better. So whenever there's features like that, I really enjoy that. So another one, kind of a small annoyance, is that you may have run into code where you have using blocks, and sometimes you'll have like nested using blocks, and it just keeps shifting your code. And what we basically introduced, I don't remember exactly which version those are, but we can now remove the braces, just put a semicolon at the end. And what this means is this using declaration is applicable to the rest of the scope. So typically till the end of the method is the most common case, and that helps to kind of keep your code from shifting out the window, so to speak. All right. So any questions so far?
We have a little bit of love. We love this.
We do.
Well, that's great. Yeah.
I believe Frederick is referring to the
fourth example, right?
Yeah,
the non-shelling
named
argument names. Yeah.
Yeah. Anything that helps.
So if you have multiple using, in which order are the objects disposed? That's a good question.
Oh, yeah, that's a good one. Those are existing rules when you have nested usings or when you have multiple usings. That's a situation that can already occur, and they get disposed in the reverse order of the declaration. So they get disposed from the inside out, and that's consistent with kind of nesting. The rationale for that, I think it kind of makes sense because a second using could be referencing the first one. So you don't want to dispose the first one first because the second one is still depending on it. So you have to kind of clean things up in that order. All right, so I'll quickly flash my slide. We'll talk about local functions. That was introduced in C#7, and that's one of the features that surprised us quite a bit because we ended up using it a lot. These are some of the aspects of the feature that I'll explain. All right, let's jump into some examples. So let me straight flash show what is a local function. This is almost like a method that is declared inside of a method. All right, that's pretty much it. It's really useful for cases where you want to extract a little bit of logic that appears multiple times, but you don't think it deserves to add to your, to the list of methods that are visible and that show up whenever you're coding with this type. Even when you're dealing with like private methods, like for your own, basically this is a way to encapsulate and keep a code local to a method. And also, it's even if you don't, if it's not a repeating block of code, it's actually quite useful to just make your code more readable by giving that block a name. So this code becomes more readable because you don't have to worry about some of the details. You can read, and you don't have to add comments for things. So it also helps for readability. Because those functions are local in the method, they actually have access to local variables and also to parameters. You can refer to those within this code. Although I didn't show it here, you could you could put those local functions, in the middle of your code, although I don't typically recommend that. But if there are situations where, let's say you need to create a local function that has access to this item. You could create a local function within this for each, and it would be able to capture this local from the for each. But in practice, what we found is kind of as a convention, we tend to just put all of our local functions at the end of the method after the return call. So okay, let's go into this example a little bit. So I have an enumerable that's coming in. I'm preparing a list, and I'm going to keep it null for as long as I can, because I may not find I may not want to ever instantiate it. We're going to loop through our items. So we're going to try and find some that are interesting. And then if some are interesting, we'll initialize our list, and we'll put it in the list. So I've created a helper local function for initializing. By the way, this is also kind of a small new feature. We have a number of compound assignments. You can do plus equals, you can do pipe equals, and you can now do question equals, which is a shorthand for testing. If found is null, then initialize it with this value. If it's not null, then just leave it as is.
I'm sorry. You can do what?
Since 7.
That
you
is since C#7, yes.
Well, I know about the dual question marks, but not that you can use it in that kind of capacity.
Right.
That's awesome.
Previously, I mean, there's multiple ways you could have done this before. You might have done found or new lists, something like that. But that always assigns something, so it's a little bit wrong. So then you might have done if found. I'm not jumping ahead. If found is null, then found equals. You do your assignments.
We have another one here, I think.
Right. So I mean, those are things that you could do before. This is the shorthand, and people were looking at this. And this is very similar to other compound assignments like plus equals, where you're kind of reading the old value and then you're assigning a new value. And so it made sense to have the question equals. So those are things that are not, these are things you could do before. It's just doing it in a kind of more natural way and kind of in line with other features.
I like it.
So what we're showing here is that this local function is using this local variable up here. We're reading it, we're assigning it. And in contrast, I have this one where I've created a parameter of the same name as a parameter that from the containing context, containing scope. And so we do allow shadowing. That was not in C#7. It was added a little bit later. But we found this is one of the situations where feedback and experience with the feature helped us refine the design. And we found it quite useful. So this input is just a local to this local function. It has nothing to do with that input. I even gave it a different type on purpose. And when you call this local function, you just pass whatever you want, and then things work as you'd expect. One thing that we found, so captures are not a new concept. You could do captures with lambdas before and delegates. But one of the things that we found useful is helping user. There's often a case where you have code that just does not depend on anything. It does not capture local variables. It does not capture the instance like this. So if in this code you were using this or something like that, you'd be allowed to. And one of the things that we found useful is, I'll add it here, allowing users to say, hey, this method does not capture anything. You can just say it's static. Now code reviewers will know I don't have to try and map things mentally from where they come from. This is a isolated block of code, and it helps me understand this kind of in isolation. So it helps for encapsulation. And you can also use the static keyword now for lambdas. So you can put static in front of a lambda. And it basically has the same meaning. It basically says you're not capturing any variables. And I mean, if in here you try to say console.write your input, then you'll get an error that says, you're not allowed in a static function. You're not allowed to reference something.
Right.
Nice.
Does it make sense so far?
It does. And the common theme seems to be easier for the user or easier to write or to read.
Right, to understand the code and write good code. Basically, that's the thing. So just like lambdas and methods, you could use like in link, right? So here I have a local function. It's basically, again, it's just like a simple filter, and you can use it in the select. So the select expects, let me pop up the, there we go. It takes a func, so, oops, nope, it's not this one. Is it this one? Oh, it is. It was that one, yeah. So basically, you can convert from a local function to a delegate type, just like you would with a lambda or even a method previously. One small thing I want to point out on that is that that's something I learned. I did not know until I started working on the compiler. So this is the code that's actually produced for this statement. So we're calling an extension method called select. We're passing the input, and then this part is the part that's interesting. So the compiler generates a method for the isInteresting local function, and we give it like a we call those unspeakable names. So those are not names that users ever see. But there's an allocation here of a delegate type. Those are things that performance oriented people already typically know about, but that's something that's good to know about. Depending on exactly how you pass your lambda or your local function into your method. The code that is generated here will be slightly different. In some cases, we'll just create a new func on the fly, but that means every time you run this code, there's a new allocation. You could in some cases we'll create one, but we'll save it and reuse it for subsequent uses. And then if you're really kind of performance sensitive, there are cases where you just want to create the func yourself and hold on to it for, make a kind of static instance or something like that. So anyways, that's a something that unfortunately you kind of, this is an instance where, like, if you really care about performance and avoiding allocations, it is useful to know, and it will be slightly different depending if you're using a lambda or local function. So that's just a little caveat. So, any questions?
We do have a question. Do you have some tool like Sharplab IO for local use?
Oh, so yes. Actually, Sharplab is one of our favorite tools. We're super grateful for Andre, the author. We have Microsoft also has like try.net, which is not quite as deep as Sharplab. Sharplab gives you decompiled code. It can show you the IL. This is where I would go and check those kind of situations that I mentioned. You can see the syntax tree, which is useful. For example, if you're an analyzer author, you kind of have to understand what the syntax looks like. This is a handy way to see what it's like, and you can even run the code and test it that way. So, and the author of this tool has been super nice, and he even mapped our feature branches into the tool, so you can even test the latest code. Some of the C#10 code is actually available to test in here, which is fantastic. So I have to say I love it. Try.net is also great, and it's more focused on learning how to code, kind of trying and running it. And one of the things that's great about it is it allows you to embed a little JavaScript or an iframe, like in your web page, where you can embed some small version of this that's functional with, like, if you're writing a blog post or something like that. So
Nice.
those are some of the tools that we use. Another tool that's kind of like this, of course, we use the IL disassembler, which comes with .NET, but ILSpy is also a tool that we use quite a bit. So,
Are any of those for local use, or are everything online?
ILSpy is a local application that you install. It's a Windows application, and Sharplab obviously is available everywhere. So. All right, let me check the time. All right, pattern matching. So pattern matching. So this is a feature that was kind of a long time desire for C#. It existed in F# and in other languages. I kind of started programming, or I learned programming in OCaml, or Camel, which is like an early influence for F#, and it's really based on pattern matching. So over the from C#7 to C#9, we've kind of added multiple waves of different kinds of patterns. So it's kind of a sub-language that is expanding, and we're planning to make some further improvements in C#10. So I'll kind of jump in with some examples. So the general concept of a pattern is to test something. So I've created a tiny hierarchy of types. So we have animals, and then dogs are animals, cats are also animals. So you can now write a switch statement where you come in with an animal and you can test the type. If it's a dog, you go here. If it's a cat, you go there. So that's pretty straightforward. Previously, you'd have to have written this with like a bunch of if statements and is expressions, basically to test the types. So this by itself is useful, but as you'll see, things kind of build up on each other's, and it's when things start to nest that it becomes quite powerful. So another one, also kind of trivial or kind of simple by itself. This time, instead of using a switch case, I used an is expression. This is a second context where you're allowed to use patterns. So you could already use, case 1, case 2, that already works. So constants can be used as patterns. You can have, integers, strings, and then I have a simple example for null. All right, now this is where things the power starts to show. So I've created a simple point which has like 2 coordinates, and I did a little bit of preparation on that type. I gave it, not only does it have a constructor, it has a method called deconstruct, and it has a kind of a signature in a certain way that we expect, which allows you to do the reverse of the construction. So the construction is taking different parts and assembling them into this instance of a point, and deconstruction is getting the parts back out. So it's kind of the reverse. And one of the patterns is the positional pattern. So it's positional because you basically write a list. You could have more commas and more elements, but this won't work because the point only has 2 elements in it. And now what we're doing is we're testing, does this point decompose into 2 parts? Is the first part a constant 1, and is the second part a constant 2? But you could imagine, since we've seen that that we have type patterns, you could test, is the second part an int, right? So that's where things start to compose. And we're going to go deep into this rabbit hole. One way of constructing a point is with a constructor and passing arguments to that constructor. Another way of constructing types is with constructor initializers, where you basically name some of the properties. So
I created that person.
I created a person. We use points and person in a lot of examples, so we have 2 properties, and this is just standard, pre-existing code. So now you can kind of use. We try to have syntax that mirrors the construction when you try to match things with patterns. So if somebody gives me a person object, I can now test, is the first name Jessica, right? So the syntax is kind of similar. And same thing, you could, here we are reading so 2 things are happening. We're taking our person, we're checking that it's not null. Then we're checking that it has we're getting the first name, and we're applying the constant string pattern to that first name. But here, you could have some other patterns, right? So string or null, or if you want to do something fancy, you could do something, a positional pattern like we saw earlier.
In that particular example where you're checking if first name is Jessica, is there any upside to using this syntax compared to like if person dot Jessica? Person dot first name equals Jessica.
Yes. So that's a good question. So all right. So if you do this, the first problem that you're going to run into is person could be null. So handling the null case is kind of a straight up benefit from this. If you want to do multiple tests as in one, then this starts the kind of old way of testing things becomes kind of lengthy and repetitive. And this is especially apparent in switches and switch expression, which I'll cover a little bit later, where what you gain from patterns is things become a lot more concise. So again, this is not something where you couldn't do it before, but we're making things really kind of compact and declarative in a way. So that's where the benefits pay off. So
yeah, we got good stuff to have the pattern matching in the language.
right, exactly. So I'm kind of building up by adding a little bit of complexity to all the previous examples. So here I'm combining a type test with a property test. So I took an object as an input. So I don't know necessarily what the type is. So, well, I know it's an object, but this test is going to first check that it's a person. We're going to cast it to that type. Then we're going to access the first name property, which obviously does not exist on objects. We're going to test that. And then we're going to give the resulting person a name. Right, so now we have a local that is of type person, which you can use, in subsequent code. So previously, if you wanted to do this kind of similar thing, you'd have to say if interesting. I take a mental note. Do I need to? Was there a bug? If O is person, then you do this. Then you'd say, okay, I have a person, and I'd do my cast, and then I would do my test, and so on, right? If the first name is Jimmy, then basically you see how all these tests are a lot more compact in a pattern form. So the next example illustrates. So it's very similar to the previous one. We're doing a test on properties. Here we have a constant pattern, and then this one is a declaration pattern. So kind of similar to what we had here, we're declaring a local called Jimmy of type person. I'm declaring a local, so the type is going to be inferred. It's the type of first name, and I'm just giving the name here. So this is for, I don't, like, you're not kind of filtering. You're not exactly matching. Anything will match. Any first name will do, and you're just saying I want to use that value for later on. If you wanted, we'll see that there's a way where you can say, okay, I want to do a test and I want to hold on to the value as well for later on. So this is to illustrate that kind of this pattern where you have like I'm going to remove the property part. So here you have a type and a declaration, an identifier for that declaration. You can use that in nested positions inside your pattern. Here's another example. So I went back to the point example, and I want to find. I want to check if my point has a y coordinate, which is 2. And then I want to grab its x coordinates, right? So I could use the explicit type like int, or I could use var. It's functionally equivalent. Sorry, there's a slight difference, but we'll cover that later. Basically, if I put the explicit type here, I'm going to verify that the type is indeed the type. So for ints, it's not so much a problem. But in the example where above we had like an object and we're testing the type, it would actually verify that this object at runtime happened to be a person. So in this case, since point, the deconstruction for point gives us 2 ints, we already know that it's an integer. We really have to test that again. So in this case, the var and the int are equivalent. So kind of the general way of thinking of this recursive pattern is that you have a type, a list of parts, you have your properties, and then if you want, you can also have an identifier. And each of these parts is optional. And I don't know if that's obvious to you, but this is very similar to the syntax you would have when you're instantiating a type. So you would say new type, pass a bunch of arguments, and then you'd have a initializer with properties in it. So that's the way to kind of remember that it's it mirrors the construction. So, all right, any questions so far?
We have a bunch of comments.
Sure.
We have so Frederick, somehow I missed the deconstruct stuff. This will be fun to play around with. And
Yeah.
Andrea says, and you need to check for null. All these kinds of nuggets, it's really nice.
We're going to talk about null a lot more in our next section.
Nice.
Yes, nulls, the bane of our existence.
We also had a comment that putting the variable at the end wasn't that intuitive.
Mm-hmm.
And the comment on that, to see it in another way, we can see it as if first name is Jimmy, put in variable Jimmy.
I'm a variable.
You are. You were also,
Right,
also
so-
objectified.
The reason I named it Jimmy as opposed to person is because we already had a person up here. All right.
It makes sense once you know it works this way. But I think I would prefer it to be a bit more explicit. Maybe like
Object?
maybe. Yeah. Oh, all right. Okay. O is person, and then first Jimmy as. Now I'm pointing with the mouse pointer, and no one can see that.
I can see it, but I'm the only one.
So you can follow along.
Yeah.
That's good. That's good.
Are you pointing at here at line 42?
No, I was actually pointing at the comment as I was reading
Oh,
it.
sorry about that. Yeah.
No. It's he was showing all the
comments.
viewers.
Right.
And nobody can see it. We do that all the time, pointing at the screen and.
Yeah.
So far I've kind of the pattern language has been getting richer over the C#7, C#8, and now we're getting to some of the additions from C#9. So not only can you check if a value is exactly 10, you can check if it's smaller than 10 or greater than 10. So we have these relational operators. We have also, okay, so I mentioned earlier you could test something and also capture it. So the AND operator is one way to do that. So for example, if you're trying to check a range, if I have an integer here, I want to check if it's between 0 and 10. You could check if it's greater than 0. So that's a relational pattern, or smaller than 10, and then you can combine two of those patterns as one. So we have the AND, we have the OR, we have the NOT. The NOT can be used in pretty much any place, but the by far the most common way that we use the NOT is on not null. And then as I pointed earlier, all those patterns can nest. So here we have like a positional pattern. We have our points. We're going to check that it has two elements, and we're going to check if x is greater than 0 and if y is greater than 0, right? So we're putting this kind of pattern in the first position of a positional pattern and our second position. All right, and then the switch expression. So earlier I showed that you can use patterns in the case of a switch statement. on the right-hand side of a is. And now this is a third expression where you can use patterns. So this, I'll walk you through for people who have never seen this kind of expression. So we have an input value, which is our I, and we're going to list a number of patterns. And if this pattern matches, then this whole expression is going to return this value. If that pattern matches, then we'll return that value. And then instead of having like a default that you have to spell out, we have a discard. Basically, this is the catch-all pattern. And in that case, we'll return 10. Sorry, we'll just return this constant, whatever. One of the interesting things, since the switch expression is something new that was introduced, it is actually a little bit smarter than the switch statements in that if you're missing, basically the compiler is able to analyze that ints have a whole range. You've just tested for part of the range, like the ones that are smaller than 10, the ones that are larger than 10, but you forgot for testing for the value that's exactly 10. So I don't know if the error message is easy to read. It's a little bit small, but I'll read it out. The switch expression does not handle all possible values of its input type. For example, the pattern 10 is not covered. So this is an advantage of patterns over kind of writing custom code, which is the compiler can provide you additional help. And we'll see that a little bit more. I mean, obviously with booleans, with types, there's a bunch of scenarios where we can check whether you've tested all cases, and then we're also planning to add some more in the future.
That's cool.
Are there any plans on allowing non-switch expressions switches be written in the same way?
I didn't follow. So you can use those switch expressions inside of. I use it to just declare local, but you can use that anywhere. The switch expression is like the big brother of the conditional expression. So previous. Like for very simple cases of booleans, you could say, here's a boolean, so I'll just use true. And then you could say, one value or another value. Right, and the same way that you can use this expression somewhere else, you can use a switch expression for handling more than two cases, basically. So does that answer the question?
He was thinking of a case. Well, it's easier if you read that. I will mess it up.
Hold on. Yep. Let me switch.
Sorry.
We get infinite loops. Okay.
That's always you need to So not returning anything, just doing stuff.
Yes. All right. So that is okay. That is a frequent request. Now I get it. So the question is that expressions are things that have type. So here I'm basically returning this value, right? I'm producing this value. But what if instead of returning a value, I just want to execute something? So I have a like a void returning method, like console.writeLine. Right. So what if I just want to execute something? So those would be kind of it's a little bit unusual. It would be like a switch expression that has a void type in a way, right? So that is something that is definitely on our radar. We have a few different proposals for how to address that. So stay tuned. Nice. Yes, that is definitely. So one of the good things is because this is currently an error, it's something that we can add and it's not going to break anyone, right? We're purely enabling new scenarios. So That's one of the reasons why we felt like we did not have to solve. We kind of kept that problem separate for now, and we were able to ship the switch expression just as like an expression that, like other expressions, is just as a type. So, all right. So something that switch expressions, switch statements, and is expressions can now do is also match on multiple values. And we'll talk about this kind of syntax a little bit more if we get to tuples. But here I have like my 2 coordinates. So I didn't put them in a point. I just have my two integers. And I want to check which quadrant we're in. So I can now match, like 4 cases. And one of the nice things about this code, even though it seems like there's some redundancy, like I'm doing a check on x, is x greater than 0 or not. Actually, we're able to detect that this is the same as this one. So this is the code that's produced is actually really good. Like you'd have to, you can write it by hand, but you have to be careful. So the compiler is helping you with that. And then similarly, since if we've already tested if whether x is greater or equals to 0, and let's say we found that to be false, we don't have to check if it's smaller than 0 because we already know that. So there's all sorts of kind of nice behaviors that emerge from patterns. One thing that I should mention, I'm going to jump back really briefly to property patterns. In general, when you have like multiple tests like this, like you're getting a property and checking it and getting another property and checking it, we've been pretty careful not to commit to any kind of ordering. So basically a strong guideline is those properties should not change anything. Don't have properties with side effects that when you use them in patterns, because for example, we're not telling you if last name is going to be evaluated. It may be evaluated, but it may not be evaluated if first name actually did not match, right? But in general, one thing we can say is that first name is only going to be evaluated once. Like we basically don't need to pull the information more than once. But in terms of ordering, that's something to kind of steer away. Do not put side effects in your patterns. That's so.
Sounds reasonable.
And I mean, especially if you have like switch cases, and imagine you have, so those could, actually I will use, I can use this one. Here you could have a property pattern where you're checking your X property and say, is it greater than 0? What was I going to say? Right. So the order of how those patterns are computed is not obvious. So again, the point is this is to illustrate in a even more obvious case. Do not rely on order of evaluation. So, and so here I kind of took this example and modified it a little bit, where I'm passing a point. And again, my point type had a deconstruct that gives me 2 elements. So now I'm doing, my positional pattern. So I'm checking that a point has 2 parts, and now I can check the parts. So this is kind of very natural syntax. So.
That's really nice.
All right, that's pretty much it. That's what I want to cover for patterns. Is there any questions so far?
No new ones.
All right.
It's like Frederick said before, you answer the questions as he types them.
Oh, perfect. He's setting me up for what I intend to say, so that's cool. Yes, I feel like, I mean, this obviously I've been going pretty fast. So this is meant to be kind of an introduction or give you a sense of what you can do. Pick your interest, go and learn more, try it out. And again, there's lots of good resources on those for more details. So now next I wanted to talk about, so pattern matching, we talked about type tests, constants, positional, so that's with the kind of the parentheses and the comma separated elements. Properties, I always say property test, but it could be property or fields. Declarations, you can have var. So, yes, let me mention one more thing about var while we're at it. So let's say you give me an object and I test, is this a person? This will only return true if the object is not null. But the var test, where you say, is my object is var x, that's the only one, I have to say, that does not include a null test. So your variable may be null after that. So that could trip some people up. It's worth calling out.
That's good.
We've also talked about the relational tests, the combinators, and, or, and not, and then the source expressions, including multiple values, and the exhaustiveness. So we're going to move on to Nullable reference types, and again, I'll start with the code, and then we'll come back to the slides as a kind of quick recap. So
we have a question if the examples will be available on GitHub or similar after the stream.
Yes.
Perfect.
So I will create a GitHub repo with this little project, and I'll send Jessica and Jimmy the link, and you guys can post it wherever it's convenient.
Yes,
perfect. Thank you.
All right.
That's a lot of good stuff in there.
It is.
All right. So nullability. So this was a big feature. The nullability feature, that was C#8 and C#8 was the big wave. And C#9 we also made significant improvements. This was the biggest feature from all the ones by far in terms of complexity and effort. In a way, it's it started in C#8. In C#9, we kind of addressed a lot of feedback, and we had warned people that to expect there will be some changes. We expect to tune things. Kind of a general thing about the philosophy of this feature is that it's not quite as exact as some other features of the language. So, for example, the C# is strict in terms of type checking and stuff like that. Nullability is a little bit more based on heuristics, and we'll see that there's some holes. But one of the things that I found from we've adopted the feature throughout the Roslyn code base. And one thing that I found is those little gaps did not detract from the value of the feature. So I found it super useful, even though it's not like a 100% strict feature like some of the other compiler features or language features. So, all right, so to set up kind of the problem, I created a simple API, takes a string, returns a string, and normalizes. So one of the questions from looking at this API, you'd have no idea, does this method accept nulls? Is it possible that it returns null? Basically, nobody knows. I mean, you'd add documentation, but there's no hints.
Yep.
And there's not always documentation either.
Exactly. Right. So the nullability, so nullable reference types is the C#8 feature, and it tries to address that. It's been kind of a long-running problem, and on one hand, we want people to, in the long term, to have a code base where nullability information is there, and the code is really clean, and you don't have to. There's no traces. Like, we didn't force you to add things just because we had to deal with, we want a clean future, but we also don't want to break people who have existing code or who are migrating. So this was a little bit delicate. We had talked about, so I mean, the basic principle is that you want to differentiate between string that may be null and strings that may not be null. The kind of the naive approach, or one of the approaches that we rejected pretty quickly, was to just say, okay, you have, there's a third kind of string, which is string from today, right? So strings where you don't know, like legacy code. So it would be tempting to say, let's add, string question that's kind of natural for maybe null. Maybe add some syntax to say, no, this one is really not null. And then you're left with string meaning the same thing that it always meant, right? But instead of that, we basically decided that string will take on a new meaning, but it depends on the context. So, all right, let me jump into what that means. So we have this directive, Nullable Enable, which you can typically we put it at the top of our code files. You can also specify the same thing in your project. If you're starting a new project, I think it might be already turned on by default, but if not, I would encourage you to just do that. So you can turn on this, I would say this mode at the project level or at your file, or like I did here for a region of code. And what it means is that when you're in a context where nullable is enabled, this string here has the new meaning that it's not null. Sorry, I realized I inverted my comments up here. That must have been confusing. I apologize. So the not null was the bang, and the maybe null was the question mark. So this string here is the not null case, and the string question is the maybe null. So this is that by itself already gives a lot of benefits, in my opinion, because it lets you clarify in your APIs what is it that you mean. Yeah. And I encourage, like, one of the things, we'll talk a little bit more about how to migrate existing projects to use Nullability. It is quite useful to annotate your API so that your customers can already get the benefits if they choose to enable Nullability from their side. And we'll see how that, what that looks like. The second benefit is that now the compiler has an idea that, hey, this input could be null. You're in a context where you care about nullability, so the compiler is going to start giving you warnings if you do things that it deems to be dangerous. So let's look into that. So most directly, if you try to dereference, like call a method on your string, on your inputs, we're going to warn and say, hey, this may be null. the reason we're warning is if you run this code, it will throw a null reference exception at runtime. So the goal of the compiler, the compiler is trying to help you catch those issues at compile time rather than at runtime. The reason why we're everything about the nullability feature is going to be warnings. So you're free to ignore them at your own risk. But there's also pre-existing project settings or compiler flags that you can set if you want to upgrade warnings to be errors. So usually, I'm trying to remember in the project, it's something like treat warnings as errors or something like that, and you would specify a list of warnings. For the nullable warning, because it's a whole set of warnings, we've introduced a shorthand where you just say nullable, and that means the set of all nullable warnings. So just a little aside for people who like to use kind of stricter settings. So all right, so here we've warned for input maybe null, and you're trying to dereference. So this is dangerous. So what should you do? So well, the obvious thing is you test for null. So there's many ways that you can test for null. We've talked about this new way. You can do is null. You can do equals null. I actually prefer is null for not too many people will run into those situations, but equals null. If you're depending on your type, it will actually call the equals operator. Whereas the is null is always just checking, is this reference null? It will not involve any. It's basically guaranteed. Whatever the type, this will not call any operators or any kind of logic. So this is always kind of it's guaranteed to be the cheapest null test. So that's the reason why I like it. And after you've tested, so there are two branches to the if. In the branch where it's null, it's still dangerous to dereference your variable. But in the other branch, the compiler is able to trace that you've returned here. So by the time we get here, we're only left with the possibility that input is no longer null. So this dereference is now safe, and there's no warning. So that's awesome. The very basic of the feature. Yes. All right. So. Oh yeah, there's one more thing I want. Okay, so we are still in a nullable context, but now I'm calling this normalize method, which is the legacy one from, it could come from another library, it could come from a part of your code that is not yet nullable enabled. So I have a little bit of a word of warning here, which is currently it's not super easy to tell that this method is kind of a legacy method. We're planning to make some improvements in the IDE to help with that, to make it a more visible. But in general, the philosophy around dealing with legacy code is that we are going to assume the best. That means you have this normalized method. You want to pass a null. Well, we're going to assume that it's fine. Similarly, here, oh yeah, I didn't mention that. Sorry, let me take a step back real quick. Here, I've declared that this method is going to return a string that's not null. If I try to return a string that is null, we're going to warn on this, right? Or if I try to directly return my input is maybe null. So I'm trying to return it, but my return declaration is not null. Here, we're also going to warn you. All right. So now let me jump back to dealing with legacy code. Here, the declared return type is a string that's not null. I'm returning something from an API that I don't know. Well, we're going to assume the best. So there's no warning here. So that's the general philosophy around dealing with legacy code or kind of migration. This is very intentional because migrating your code, so it's not, in our experience, it's not been terribly difficult. Most of the time, you have to just enable the analysis in your file. You add a few annotations, you fix a few bugs, maybe you add some null tests, those kind of things. We'll see a little bit more about that later on. But still, it can be a significant effort. That's one reason why we encourage people to migrate like file by file or parts of your project at a time. Because if you just enable, depending on the size of the project, if you just enable the analysis on your whole project, it will be a lot of warnings. So we did not want to flood people with even more warnings that may not even be valid. So when dealing with legacy APIs, that's why we can assume the best. So
that's good.
All right, how are we doing on time? We have about 10 minutes left, is that right? Or more?
10 minutes or however long you have.
Yeah,
right.
So if you have more time, we have more time.
All right, then we'll go on. I would love if we can go through at least finish the Nullability. I think that would be really helpful. And I'm happy to stay on longer for people who are interested to learn a little bit about tuples. But basically, that was kind of my goal, is to reach Nullability. So I'll be happy. All right, so I mean, we've already, so the basic concept is that the compiler tracks for each local is going to track each local that is a reference type is going to track, do we know if this may be null or if it's not null? So our local O has a state. When you do a test, we know that in this branch of code, it's null, but in that branch, it's not null. So each variable has a state. How about a person? A person has like a first name and a last name. I added a middle name as well. And the middle name, I don't know if you can see from the quick info tip here, it's a string question. So the middle name is optional. So one thing, I'm going to combine this with kind of earlier patterns. So if you test that your middle name is not null, then the warning on middle name goes away. So there's kind of an assumption here. We're not only tracking the variables, we're tracking the fields of those variables as well. So p.middle name is something that we're going to start tracking as you test for null. And the philosophy there is that, yes, I remember what I wanted to say. So person is in this case, it's a struct for whatever, for reasons that will come clear later. But imagine if it was a reference type. Somebody else in your code, you could have multi-threaded code, and somebody else is using the person instance and could be modifying it. It is possible that between the time that you're testing middle name and then you're using middle name, it's possible that it actually changed. If you set yourself up for those kind of problems, you have to be careful. I mean, this multi-threaded code or concurrent code is difficult. As far as nullable analysis, we assume that does not happen. So if you're telling us, if you're testing that something is not null, then later on we will stick with that. So that information or that state is going to be sticky. So okay, now for the reason I made person a struct in this case. So here I'm initializing a struct to be default, which means that even though I'm going to briefly jump to my definition, even though first name is declared as not null, it is actually still possible that it's going to be null. Because for all structs, it is possible to construct a struct that is basically uninitialized. So that's something to be a little bit careful with. This is one of the kind of holes. I'll point out some other ones where you can still get a null in a place that you did not expect. So it's not designed to be airtight. Here, what I want to point out, so because unknown person is unknown, it's uninitialized, and I'm getting the first name, even though first name, that API is declared as, oh, actually, sorry, I made a mistake. This is a case where we are able to track it. So this is not a case where we have a hole. Even though first name is declared to return a not null string, we are able to know that it actually may be null. And the specific one, so you'd get a warning here if you try to dereference it. But the specific warning that I want to call out is that I'm assigning to a local. That local has a type, and you have the choice, the same way that I showed you in the signature of the method. You can annotate or not your local declarations. If you assigning something that is not null, assigning something that is maybe null to a local that is declared as not null is going to be a warning. We consider those warnings to be kind of less severe. It's always a very specific error code. It's the 8600. Some people may choose to silence that warning because that is not dangerous per se. Really, we'll still warn you later on if you try to do something dangerous with that variable. But in terms of code hygiene, if you're declaring your local and your intention is that it's not null, then you should probably not put stuff that is maybe null into it. So that's my point. Is there's two kinds of types of warnings. There are warnings that are clear indication of danger, and then there's this warning for assignments where this is not dangerous yet, but it's also not great. And usually this is one of the reasons why we produce this kind of warning is because let's say you have only this warning on the actual dangerous, like the dereference, or maybe you're calling an API and you're passing that value in, and it, we're going to check there as well. You're going to probably have to go back up here and fix something up here. So it's useful to point out, the root of the problem. var declarations are slightly special also here, because there's no way to say var versus var question. It turns out, although that's tempting, it turns out that is kind of a puzzle that cannot be solved. So what we ended up landing on is that vars are made to be nullable by default. So even though I'm initializing it with a string, so you could think, and this is obviously a not null string, you could think, hey, the type is going to be not null, but in fact, it's going to be a string question. And the reason for that is because you may want to assign nulls later on, and because there's no solution where you could tell us the difference, like this is a var that is meant to accept a null versus a var that's not meant to accept a null. And var, the philosophy of var in general is, I don't really want to bother like telling you the type. So probably I also don't want to bother telling you the nullability. So we took kind of the more lax option for the var, and that means you're allowed to assign a null to that local. And of course, we still check. Here it's okay to dereference because we know it's not null, and you assign a null. We keep track of that, and so later on we can warn you.
That's good.
So now, as for the actual gap, so that's an actual one. So when you create an array, we don't really have the ability to track each person, like all 10 people that are like in each slot of this array. So at that point, we're going to fall back on what the API tells us. So first name says it's not null. We're going to trust that. So in this case, I assign it to a local that's not declared as nullable, and it's fine. And I could also dereference it, and it would be just fine. But this code would actually blow up at runtime. So this is, in general, right, that comes back to the philosophy of, hey, we could warn you here, but this is actually, it could be, you could have perfectly safe code, and we'd end up producing code that, warnings that would be annoying, and we thought that would detract from, people adopting the feature. There are still cases where the compiler is not quite able to track. It could be that you have in your code you have a convention that if a certain variable if a certain field is in certain state, you know something about another field, right? You may have like kind of contracts or expectations invariants. So what do you do in those cases? Like, how do you get rid of the warnings? The compiler is obviously missing something that you know. How do you help the compiler? So the most common solution for that is to add an assertion, which makes your invariant explicit, and you're telling the compiler, "Yep, middle name is not null. I know that." And now the warning on using the middle name, which was, we had a warning here. The assertion makes the warning disappear. This is what I would recommend for kind of invariants that are like through your program. It is also possible, in this case, like I had a method or property that I actually checked within this code. I already checked that I have a middle name. There's a second option that you can use here, which is the bang or like the suppression operator. And basically this, it's meant as a be quiet. It's meant to silence nullability warnings. You can use them in a bunch of places. As a guideline, we kind of recommend those when there's something in the method of your body where you already checked. So this is just a case where the compiler couldn't tell. If it's something that you didn't check, like if I didn't have this check up here, I would recommend the assertion, which is more explicit. And also the assertion will definitely catch, if you made a mistake, it'll actually catch that in debug mode. And then because this is this situation that happens to be pretty common, where you have one property that tells us about another one, we actually augmented the language with some attributes. I won't go in a ton of details on those, but you could actually annotate this attribute, this property has middle name, to say, if this property returns true, that means middle name is not null. So the way you would say that is you would say member not null if, so you would say middle name is not null if true. So I won't go into a lot of details, but for a little bit more advanced scenarios where you have there are common patterns that people run into, and we try to kind of help with that. So, but worst case, you can always fall back on the suppression or assertions, or obviously, as we talked about earlier, you can just add a null test if you're. But the null test will emit some code, and so it will actually execute some code at runtime, whereas the assertion and the suppression will not cost anything, at least in release code. So. All right. Generics, I will also be. I won't go super deep. Generics are a little bit difficult, because if I give you a type parameter t, well, for one thing, it could be a reference type, but it could also be a value type, so you don't know. And if it's a reference type, well, how do you tell if it's going to be a nullable, not nullable? So all that is supported. You can say t question. T question has a little bit of a special meaning, because it means if it's a reference type, then it's nullable. If it's not a reference type, then it's just a t. So there's a little bit of subtlety for generics, but in the most common cases, I mean, the big point is that you can use nullable or non-nullable types in as type arguments for generic types. So here I have a list where the elements are expected to be nullable, and then I have a dictionary where the values are expected to be not nullable, and things will just fall out from that. So even though list is generic, once you plug in a string question in here, well, the add will accept nulls. And when you do for each, so there's like, it will call get enumerator, and then it will get the items. Well, the items are going to be nullable because you've declared your list to be a list of string question. If you change that, then you get a warning when you try to add something, but then the items that you get back are considered to be not null. Similarly for the dictionary, so adding a null is going to warn, but getting an item out is going to give you a string that's not null. And then I'll point out a kind of useful pattern. There are some methods like try-get-value, which return a value in a out variable, but depending on if it returned true or false, well, if it returned false, the out variable will always be a null. So that's kind of tricky, and it would make it really annoying, because like inside the if, you want to use the value that you got out of your dictionary, and you don't want to add a null check, because your dictionary is already declared as a string, a non-null string. But at the same time, if you use that as elsewhere, we should warn it's dangerous. So again, here we kind of used some additional annotations. So if we went and looked at this, the definition of this API, you'll see that there's an attribute here on the out parameter, which tells which hints the compiler about some kind of the nullability contract of this API. So in general, it will return a value of the same type that you put in the dictionary, but if we're returning a false, then you'll get a null anyways. And so here I had to declare my out variable to be a string question, otherwise there's a warning. But when I'm inside the branch, we don't get any warning, because the compiler knows that this returned true. Therefore, we had a not null string here. So those are some of the subtleties, but the base class library starting from .NET Core 3, I want to say, and definitely in .NET 5, has been updated, and so it's designed to be usable.
That is simply beautiful.
We're hoping that most people do not have to mess with attributes too much, but they're there basically for those difficult situations. I'm not sure if I can. Yeah, there was there were some situations where the analysis of like assertions and attributes started working together, and where it was really nice. So for example, if has middle name here had this attribute as we discussed, I don't even need to do an if, I could just do a debug assert, and the compiler would know, hey, this returned true. The assert method has a specific attribute that says it only returns if it's true, and therefore this is going to be not null. So there's like really nice things that fall out that kind of felt magic at the time. So that was fun. Just to mention, some of the attributes that exist, but I'm not going to go in a ton of details. If you have like a ref parameter, what if you have, so in this case, I had like a string that may be null. What if, so the ref means there's a value coming in. The method is going to have a chance to change the value, and then the caller will see that new value if it changed. So what if this method is going to say, okay, I'm accepting that the value coming in could be null, but then when I'm done with it, it's going to definitely be not null. There's no way that you could just tell that with a straight type, because the value coming in is maybe null, the value coming out is not null. So we have an attribute that helps with that. It's not null. One thing I'm going to point out here is not only are we going to, those annotations are useful for callers, but we also try to check that your implementation is compliant with what you're declaring. So in this case, I'm putting a null in my value, and I'm returning. Well, you're going to get a warning here that says, no, you're not supposed to return if leaving this value as a maybe null. You're supposed to assign something. So then if you actually did assign a not null value, then you're good to go. And conversely, so this is for values that are not null kind of on the output, but you could say I have a method where I'm expecting somebody to always give me something, and I might consume it. So I called, I might leave it in a null state when I'm done with it. So you have attributes for kind of the inbound contract. We call those pre and post conditions. And then on the caller, if you try to pass a null in there, even though it's declared with a string question, we'll say, no, you should, I'm going a little too fast. You might be assigning a null in here. So if you change that to be a not null value, then you're good to go. All right, let me take a breath. Any questions, or does it make sense so far?
It makes sense. No questions.
All right,
so
awesome.
Chat room, if you do have any questions, please type them out.
They're returning null.
All right, and now so generics, the last two parts are a little bit more subtle, but again, my intention here is to just give you some awareness of what's there, and you can always find more information. So we talked about how we did not add a bang, like a exclamation mark syntax on types, because in the long term, we don't want code to be polluted with like question marks and exclamation marks, everywhere. So at least we got rid of half of them. And we assumed that most of the time, the most common one would be the not null one. So that's why we picked that as the default. So the reason I bring that up is because when you're in a nullable context and when you're reading constraints, those constraints are also affected by the nullable context. So one way of reading the class constraint is it's a class with an exclamation mark. All right, so that means this T is going to be, not only is a reference type, it's a not null reference type. That means if you want to open it up and say, I don't care, you could give me a nullable reference type or not nullable reference type, either way, then you have the class question. And obviously, since this one is not null, you can use it either with a no question mark, then it's definitely not null, and you're free to dereference it. Or you can also say this input is nullable. So you could have a mix and match where some of your inputs are the nullable version of your T, and some inputs are the not nullable version of your T. So another kind of thing worth understanding is if you have a base type. So I have a reference type, just a class. Same thing here. So the way to read this is there's kind of an exclamation mark here. This is not null. So it has the same meaning as class. And then there's always the case of a T that is not constrained to a class, a struct. It doesn't have a base type. Those are a little bit less common, but still, there's a special constraint that we added called not null, and that means whether it's a reference type or a value type, you're good to go. You can dereference it. It does not contain a null. So those are the constraints. And then the last section on nullability, actually that's one more kind of subtlety around constraints. So all right, so in my base type, I've declared a virtual method that is generic. It takes a T. There's a T question, and I've alluded to that. T question is allowed on. Actually, I'll just jump to. If you go on the override keyword and go to definition, it will go to that definition. So you can see that there's no constraints on my T here. Right? T question is still allowed. It means if it's a reference type, then it can be nullable, and if it's not a reference type, then it's just the T. So let me expand on that just a little bit. If you took your method and you put an int, the parameter to your method is just going to be an int. It's not going to be a int question, all right? Because int question really means system.nullable of int, which is a different type. But the nullability feature does not actually change your code. It doesn't change what is produced. It doesn't change types. It's just little hints and annotations and then warnings. But we don't change what is actually produced and so on. So whereas if you put m of string, then your parameter is going to be maybe, it's a string, the type is string, and it's going to be maybe null, so it's a string question. And if you plug in a string question, well, the type is a string, and it's maybe null, so the parameter is going to be also a string question. So that's kind of a little bit, you have to just kind of know about that one. But one subtlety that this introduces is that now you want to override this method. This method may come from another library, and there could be multiple overloads of that same method with different constraints. There's all sorts of situations. But the point is that when the compiler is staring at this declaration, this declaration was actually legitimate before the nullability feature. But what it meant was this is system nullable of T. And so the compiler is going to complain that we can't find the override because there is no method to override that takes a system nullable of T. And this is one of the scenarios where we were a little bit stuck because of compatibility and legacy code. This is legitimate. You could have an override of this that looks like this, before nullability feature. So we added a constraint that basically said, so okay, what this means by default is it means system.nullable of T in an override. But you can tell us, no, there's really no constraint on this T. Don't assume it's a struct. So we didn't have like a better way of saying there's no constraints. So we ended up saying this is the default constraint, which means no constraints. So this is the way. I just wanted to mention that because it's not super obvious. People who run into that situation, they could be looking at that and actually found a bug that we're going to fix that soon. If you use the automatically generated override, naughty ID, we're not producing the constraints. We produce code with an error. So we're kind of leading users to be in that situation, and that it is not a that's not the best situation to be in. And then whereas if you did not have if you had a struct constraint or if you did have a struct constraint, then adding the question mark means you're dealing with a system.nullable of T, which means it has a has value and a value and all that stuff. So that's pretty much it for nullability. I'll jump to the kind of recap. We talked about now you can differentiate between a nullable string and a not null string. You do that with the context, which is nullable enable in your source. There's a corresponding nullable disable and nullable restore for cases where you want to just enable like a portion of your code. You can also enable at the whole project level. We talked about the analysis and the warnings are produced. In terms of migrating code, I recommend annotating file by file. And then once you're done, you can remove all those nullable enables in your source and you can enable at the project level. We're going to make some improvements to help people detect that they're still depending on oblivious code. So right now, let me jump back to that real quick. Here. Yes, let's say that I put the result of normalize into a local. If you recall, we said we're always assuming the best from legacy APIs. So the value that we're getting out is not null. And if you look at the quick info tip that you get here, we'll say, yeah, S is not null there. But you're using a legacy, like a legacy API in your method. So really, we shouldn't be too sure. So we're going to make some adjustments to at least this message and maybe even to like this color or something to make it a little bit more obvious that we're not as sure as we'd normally be. So but that's kind of a transition phase. Once your code is completely annotated, so the libraries are getting annotated now the feature has been out for almost 2 years. Like at least at the bottom layer, a lot of APIs are now available and are annotated. So we talked about, there's still some gaps. That goes back to the philosophy that we're not trying to be 100% safe. We're trying to be useful and we picked heuristics for kind of trade-off of being more useful than being annoying. And then dealing with like, okay, you can obviously add null tests, you can add assertions, you can add suppressions, and then we talked about generics and constraints and attributes. Those are kind of the more advanced scenarios, I would say. So that's it for the nullable reference type. Let me check how we're doing. All right, let's, if you guys are still okay, and is there any questions?
No questions so far.
All right, then I'll give a really quick rundown on tuples. We won't get to records today, but all right, for tuples, I've kind of snuck in tuple here and there in the prior examples. Tuples, first, it's a kind of mathematical term, so it can be a little bit scary. It's like monads and stuff like that. What it just means is like it's a bag. So you have arrays. Arrays have a number of elements. They're all the same. They're all matching, and you kind of index at different positions. Tuples are a little bit like arrays, as in the sense that you're putting different elements together. But the difference is the types could be different. So you could have an integer and a string. So you could create your own type and say, I have an integer and I have a string. It's a pair. But usually it can be a little bit burdensome to have to declare those helper types a lot in your in your code. So tuples help with that. Tuples kind of started from the observation that it's possible to pass in multiple values into a method, but it's kind of a pain to get multiple values out. Typically, you have to declare your own type. So tuples kind of step in, and they use a syntax that mirrors the syntax of parameters. So you can have types, and you can have types with names. We'll talk about names a little bit more later on. But basically, this is saying this method returns a pair of ints, or I return an int and a string. So this is a type declaration, and then this is a literal, like a value. And you're just putting two values together and returning it, and the types match, so everything is hunky-dory. What is it like when you're calling this method? Oh, I changed the signature. All right. So when you're getting the value back from this method, there we go. Well, you can declare it local of that type, that same type, the tuple type. I'm going to use pairs. So just int for all the examples, but you can make them as complicated as you want. There's actually no limit. In practice, I don't think people, I think a few elements together is the most common case, because it would just be really hard to read if you have like 20 elements. At that point, you're definitely better off creating a type and give everything names and kind of tighten things up. So this is a type, this is the name of your local, and then to access the elements, you just say .item1, .item2, and so on. You can do a little bit, hold on, Oh yeah. So you don't have to spell out the type. You can use var. And then item 1 and item 2 is not very informative. So one thing you can do is you can give your elements a name. And then you're able to just access. Here I could still do item 1. Oops, if I can type it. Or I can use first or second. And we basically pick up the names that they gave here. You can specify those names in same thing, like wherever you have a tuple type. So like in the return of the return type of your method, you can also give names. In general, we don't recommend using tuples in your public API. We recommend actually just create a type for that. Types have some benefits in terms of one, documentation, and two, in terms of evolution. So when you want to version and make changes, add new properties, it will be easier if you use a real type. So what we found is that using tuples like inside your your code base is totally fine. In your public API, it would probably cause more problems. Along with, so okay, what we've seen up here is that we were declaring one variable, but the type of the variable is a kind of a tuple, like a pair. What if you, like a lot of the time, you just want to get the two elements? Why give the tuple even a name? So we have a syntax for that. It's called a deconstruction. And it looks still very much like a tuple syntax. I did not have to put a name up front. And the way to read this is like two declarations. So as if you had int first equals something and int second equals something. And the parts just distribute, right? There's a variant for, again, people who don't like to type names. You can use var, on individual type names. But if you're extra sparse on characters, you can just put a var in front of the whole thing and don't bother. Basically, we'll figure out the types from the right-hand side here. And this is also possible in a for each loop. So here I have a list. Oh, yes. So this is interesting for two things. One is I used a tuple as a type argument. So it's a list of tuples, which means when I'm enumerating the elements are tuples. And so you could just say var t, and then t is a tuple type, an int string. Or the way I had it initially is I directly deconstruct, and now I have the int and the string, and I can just use them. And I briefly mentioned that like when we're talking about patterns and positional patterns, that's where we saw this kind of syntax with the parentheses and the commas. We talked about special deconstruct methods that have a special shape that give you the elements back. I don't have an example that's quite cooked up for that. But if you have a type with a deconstruct method, you can do exactly the same thing. So tuples can deconstruct, and types that have a deconstruct method can also deconstruct. And the deconstruct method, if it has like 3 outputs, then it will only deconstruct into like 3 elements, basically. So that's it for a super quick overview of tuples, and then we'll have to keep other topics for another time. So I will briefly look at this. Yeah, we talked about tuple types, tuple literals. So tuples are lightweight grouping of values. You can give the elements different names. We don't recommend it for a public API, we don't recommend it for public APIs. And then we briefly mentioned the deconstruction. So that's it.
So much useful stuff.
Yeah.
It was
This
a
has
little bit
been
like
a
a
gold
storm
mine.
going through, but
Yeah, and I think at least everyone has found, or everyone has found at least one thing that is definitely on the we need to try this list. Definitely.
yeah.
And we will put the resources on.
I will send you the slides, or I'll post
YouTube?
them online. And again,
And on
if you go to
Discord.
C#Lang or to Roslyn repos, we have a list of features. Microsoft Docs has also a lot of good documentation. Bill Wagner and his team did an excellent job on that. So, and nowadays, I don't know if you noticed, but docs@microsoft.com also allows edits. So you can propose changes like on GitHub, which is really convenient for the community to. You found that there's a hole left, or something was not clear. Well, leave it better for the next person, and we thank you for that. So.
That's awesome.
For some reason, this isn't working on linking.
Oh.
Stuff. But we will put it on our YouTube, our Discord, and on Twitter as well.
Yeah, so if you're watching this on Twitch, which you probably are at this point, you will be able to see the links down below.
Yeah.
You mentioned C#10, so we're still working on it. There are some features that are basically ready. So we added record structs in C#9. Sorry, we added records in C#9. We're adding record structs in C#10. We're adding global using directives, which are basically, it's gonna make a number of scenarios. Oh, I forgot one thing. I forgot probably a lot of things. Top-level statements, I meant to mention that currently, if you just want to write a little program, you have to create a type, you have to create a main method. No longer. You can just put your code at the top level of your file. We will create a type and a main method for you. You can still use local functions. That's pretty handy. And the reason I was reminded is because basically we're trying to make it easier for kind of almost like scripting. We're taking steps towards lowering the barrier for like really simple tasks, notepads, those kind of things. The same way that we had a using where you don't need to put the braces and indent everything, we're going to do the same thing for namespaces. So just put one namespace at the top of your file, and you don't have to have everything indented, which does not, add a lot of value. So there's small things that are kind of nice conveniences. And then we're making a number of improvements around lambdas, which are going to, like, in particular, help ASP.NET scenarios and make really, really concise and clean ASP.NET like simple projects where you can evolve towards like a full-fledged. But anyway, so you can find a lot more information here. So it was great to meet you guys.
You too.
I'll send you the information.
Awesome. So much useful stuff.
It was.
Yeah.
Took me back to school.
Thank you so much for everything. It's been
all right. Have a great rest of the day. And
You too.
I think did you guys already schedule some follow-ups on search generators or other topics?
Not yet.
Not yet.
We're working on
We're
it.
I think we're hoping to do some deep dives on some of those. So cool.
Awesome.
With
Nice.
other people from the team.
So thank you so much.
Thanks,
And
everyone.
we'll be back. Well, we don't have anything scheduled for next week. Maybe we will get something scheduled.
Yeah.
So hopefully in a week. Thank you. Bye.
Bye.